In this video, we'll look at how to do probability distributions, and we'll compare two different expectations. So the first thing we're looking at is an 8-sided die, and its faces are numbered 3, 6, 9, and so on, all the way up to 24. We'll call that the A die. And the B die is a 12-sided die. Probably should be a hyphen there. 12-sided die. And its sides are numbered 2, 4, 6, and so on, also all the way up to 24. So the question is, which die do you expect to roll better on? Which one has the better expected value? So let's calculate the expected value of the A die. Well, the expected value of the A die is just going to be, we have to figure out the probabilities and times those by the values. So it's got a lot of writing, but it's easy. You could get a 3 on the 8-sided die. What's the probability of that? 1 out of 8. Or you could get a 6. What's the probability of that? 1 out of 8. In fact, they're all 1 out of 8. It's just going to be each possible face number. I got to write them all out. All the way up till 24. You should have 8 numbers. I'm just adding 3 each time. You could also get 18 or 21. And each of those possibilities, including the very last one, has the exact same possibility. If it's a fair die, 1 out of 8 chance. So that's 3 out of 8 plus 6 out of 8 plus 9 out of 8 plus 12 out of 8, 15 out of 8, 18 out of 8, 21 out of 8, and 24 out of 8. No, when we're adding fractions, we keep the denominator and we just add all those numerators up. You know, you can add them up on your calculator, but there's a nice shortcut here you might notice. This one, 3, and this 24 are 27. So is 6 and 21, 27. So is 9 and 18, 27. So is 12 and 15, 27. You can just do what's 27 times 4, and you get 108. If you don't believe me, you can actually add them all up, but look how much longer it takes. 3 plus 6 plus 9 plus 12 plus 15 plus 18 plus 21. Did I miss a number? And I still get 108. Nonetheless, I also want to figure out the expected value of 108, which is divided by 8, and I get 13.5. So that means for die A, you expect to get an average roll of 13.5. On a long enough timeline, you'll roll about 13.5 on an average roll. What's the expected value for the 12-sided die? Well, it's got a 2 with a 1 in 12 chance, plus a 4 with a 1 in 12 chance, plus a 6 with a 1 in 12 chance. And we're going to write down all the numbers going up by 2. There's a lot of them. But each of them has a 1 in 12 chance of occurring. That's a 12-sided die that's fair, and we're going to assume it's fair. What am I on? 20 is 1 over 12. 2 more. Whew. So, that's 2 over 12, plus 4 over 12, plus 6 over 12. Now I'm just doing, in case I didn't explain it up here, when you're multiplying a whole number times a fraction, it's just like 8 over 1. So you do top times top, bottom times bottom. Or you can just remember, when you're multiplying a whole number times a fraction, it's just like multiplying the top. Again, because it's 10 over 1, 10 times 1, 1 times 12. So we just get a nice set of fractions where we're just multiplying the tops and the bottom stays at a 12. Which is great, because then when we go to add them together, that's easy when we have a common denominator. That's why I didn't reduce or modify any of the fractions. I left them all at a 12, so that on this third line, it's all at a 12. And again, it's nice here. We have 12 numbers, but notice this and this make 26. This and this make 26. I'm going to have 6 pairs of 26. What's 26 times 6? 156. If you don't believe me, you can try it. What's 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus 14 plus 16 plus 18 plus 20. You have a chance of making a mistake here too, but you still get 156. And what's 156 divided by 12? 13. So this die, even though it's got more sides, it has lower numbers. On average, it pulls up a 13, whereas on average this rolls a 13.5. Obviously you can never roll a 13 or a 13.5 on either die, but on average that's what you'll get. Which means, to conclude, therefore, the 8-sided die is better. And what did the question ask? It didn't word it as better. The question was more asking which one has the higher expectation. I think it's better, but that's because the 8-sided die has the higher expectation. So that's how to compare expectations using distributions.